Yes friends, I am Professor Kumar and you are learning on the Galaxy Online Learning channel, YouTube channel of Galaxy Tutorials. This is a very important chapter, periodic classification of elements. Let us see what is important. We are dealing with all the important stuff, made very simple for you because the chapter appears very difficult otherwise. Historical. How do we classify elements? Why do we classify? Who started it? Are a lot of questions which come to our mind. Especially when the chapter is difficult, we have more queries about it. Johann Doberiner, 1829, he was the first to organize. Before him, nobody had organized elements in a periodic table. He arranged them by their properties. All are shining, all are metal, all make sound, all react in a particular way made by properties. He grouped them in groups of 3 and called each group a triad. Okay? Example, lithium, sodium, potassium. They all look alike, they are soft to cut and they all react with water. So, lithium 7 and sodium 23 and potassium 39 is the atomic masses. So, he says atomic mass of the middle, sodium, is lithium plus potassium divided by 2. First and the third divided by 2 will give you the second one. That is how we showed the table. So he did this as I showed you below. Now chlorine, bromine, iodine he has done. Okay. And the elements have some chemical properties to be coming into triads. All are metals. For example, is that sodium, potassium, and all react with water to form alkalis. So he chose chemical property to make a group. And all have valency -1. They all give one electron. Another example from Doberiner, we take calcium, mass 40, barium 137, we add, we divide by 2, we get 88. The middle element, cerium, is 88. Now these elements, why we form this triad? All are metals, all are alkaline, and all have a valency 2. Let's take a third example. Chlorine, bromine, iodine, halogen group. Chlorine 35.5, bromine 127, divide by 2 is 80, iodine, sorry, divide by 2 is 80, and 80 is for bromine. How do we make the triad? All are non-metals, all react with water to form acids, and all have valency 1. Okay? What are the limitations of Doberiner's triads? He failed to arrange all the elements after calcium. He could not do. They were not having similar chemical properties and all were not discovered. He failed. Next person who comes to periodic classification is Newland's law of octaves. Newland. Music, sa re ga ma pa, 8, this one, the 7, these are there, 8th is again the repeat of the first. So when elements are arranged in order of increasing atomic mass, mind you, till then only weight was being used. The properties of the 8th element, 1, 2, 3, 4, 5, 6, 7, 8th, are repetition of the properties of the first. So every 8 will have first. So 8, 9, 10, 11, 12, 13, 14, 15 again will have same. He divided them into 7 elements ka rows, as you can see on the board. And the 8th element, for example, sodium should be like lithium. That is what he said. Why did he fail? Poor guy, he also was unable to find elements for only, as I told you, 56 known. He also could not go further or would not fit in the table with properties. Properties were unknown, they were just being discovered, so he failed. We come to Mendeleev. Mendeleev, as you can see, Russian scientist, he prepared such that those which have similar properties occur in the same vertical groups. Group 1, 2, 3, 4, 5, 6, 7. Okay? And Mendeleev said properties of elements are periodic function of their atomic masses. So, when I have in a row, they will have similar properties. He made 7, afterwards 8th was discovered. Okay, so he has put separate. Inert gases, etc. Now you can see he made 7. 7th is radioactive. So till 6 I have put. So you can see 6. Now as you can see, why did he put hydrogen in metal? Sodium, potassium, rubidium, he could not explain. Number one. Number two, he put 2 in certain blocks. You see? So this was giving trouble. Today we separate the lanthanide and actinide separately. We don't put them in between the table. So this is looking like box in a box. So this was his, so 8 rows and 8 columns and 7 rows. Okay. Now, so I put there 7 period, 8 groups. 7 are normal and 1 is transition in the end, which are showing multiple properties. He left gaps for unknown and he said when they will be discovered, you can put them there and the table will remain same. What are advantages? First, atomic mass he used. Second, he left gaps. Gallium, scandium, germanium and inert gases and talked about their properties. They were not known at that time. He predicted proportion of several elements based on this. Gallium will come and sit here, scandium will come and sit here with position. He corrected atomic weights of some element like gold, platinum, etc. at that time. Now, the table from your textbook shows Eka aluminium he named, he did not know, new aluminium, after aluminium. Today we know it is gallium. 68, 69.7, 5.9, 5.94. Melting point low, only 30 degrees. Chloride ECl3, GaCl3. Oxide E2O3, Ga2O3. Amphoteric, amphoteric. So, actual prediction without having the technology of the modern times. Okay, what are the mistakes? First, he cannot explain isotopes. Today we say chlorine is 35.5. Second, wrong order. He placed nickel before cobalt based on properties. Okay, so he could not explain why. So we come to modern periodic table. We owe it to Moseley, who's given us the law which we are using till today. We follow atomic numbers after Bohr's theory was of shells, some shells was discovered. Electronic configuration, we go by atomic numbers. So it has horizontal rows, periods, vertical rows, groups. Okay, so you can see these 1A, 2A, 3, 4B, 5B, these are groups. And 1, 2, 3, 4, 7 are periods. Okay, he died very young, 28, or God knows where he would have taken chemistry. Poor guy in a battle got killed. Very, very brainy chap, but unfortunately, so today's periodic table we owe to these people for changing it. This is the long form of periodic table. You can see first row, hydrogen is an anomaly, we do not know where to place, so we have placed them on top because of electronic configuration. All are alkali metal, all are alkali earth metals. Then all these rows are transition metals which make more than one compound. Okay, these are, we are having metalloid like things. These are non-metals. Okay, these are, as we know, all of these are halogens and these are inert gases. So this is how different colors show you different arrangement of different elements in the period. Lanthanide and actinides are placed at the bottom, not 2 in each box. Okay, we are putting them in a separate position. Now, let us see how to write an answer. 7 period, 12 groups. First period, 2 elements. Second period, 8 elements. Third period, 8 elements. Fourth period, 18 elements. Fifth period, 18 elements. Sixth period, 32 elements. And seventh period has the rest of the elements. Characteristic of period and groups are, what are the trends? Atomic size. Atomic size is the size of the atom or the distance of the nucleus from the outermost shell. Along the group, size increases. Okay, for example, lithium and potassium, we have like that examples because lithium is atomic number 3, 2 electrons in the first shell and 1 electron in the second shell. Shells are named as K, L, M, N, etc. because they are in German. As we move down the group, when we come down, new shell, and the size will go on increasing. Along a period decreases, because every time a new electron is added to the same shell, electrons are being added, okay, nuclear charge increases, it attracts more and size decreases. Okay. Ionization energy. The energy required to remove loosely bound electron, loosely bound outermost shell, along the group it decreases. Easier. And as we move down, a new shell is being added. So nuclear charge decreases because the distance increases, size increases. So less energy is easier to pluck from new shells. But along a period, a new electron is added, nuclear charge increases by 1, size decreases because of more attraction, and more energy now is required to pull out the electrons. Okay? Metallic character. Metallic character is the tendency to lose electron, and non-metallic, of course, the opposite, tendency to gain electron. Along the group, metallic character increases because size increases. Okay, nuclear charge decreases and metallic character increases. Easier to give electrons. Lithium is the least. After that, sodium, potassium, rubidium, cesium, francium is the most metallic. Okay. Along a period, okay, which we have put down, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, metallic character decreases. Opposite is non-metallic character increases. I made a chart for you. Metallic character in a period decreases. Okay, in a period. In a group increases. Opposite is non-metallic. If you gain, you do not lose. If you lose, you do not gain. Non-metallic decreases, increases. Easy to remember. Nature of oxides. Along the group, basic oxides increase. They become more and more basic along the group. And along a period, nature of oxide decreases. And acidic nature. In the end, when we go, they turn out to be acids like chlorine, etc. So, nature of oxide increase, and here it is. Also, we can see acid. Chemical reactivity. Along a group, it decreases. The arrow shows ulta. Fluorine is the most reactive, iodine is the least reactive that way. In non-metal, but in metal, it increases. So, francium is more reactive than sodium. So, along a period, it decreases and then increases. Okay? Electron affinity. It is the amount of energy released when an electron is added. First we removed, now we are adding. It is opposite of that, electronegativity. Along the group, it decreases. So, when we go down, lithium, sodium, potassium, we find that the electron affinity decreases. Okay, because new shell is being added, nuclear charge decreases, size increases, so less energy is required to remove an electron. That's why. Along a period, it increases. So, sodium, magnesium, aluminum, silicon, we find that it's more and more difficult to attract electron to the outermost shell. Why? Nuclear charge increases, size decreases, nuclear attracts more, therefore large amount of energy is released. It becomes more and more better, stable. Okay? So these are the main items which you should study for the periodic classification of elements. The book has lots and lots, but this is all what is most important. And I remind you, please register yourself to collect your study packs which contain all the question answers, more notes than these. These are presentations for you to understand. They have been made simple, detailed, and questions which come from out of the book are all added in the study pack, past paper question, etc. Memory charts, how to remember, diagrams. So kindly see that you register quick and collect your study pack. Please subscribe to the Galaxy Online Learning channel so that you always are notified immediately as soon as I put, because this takes a lot of time to first prepare, fit nicely, make them particular size, present it to you. This takes longer time, my friend. Remaining detailed notes we are giving. That also extra time. These are not copied as notes. These do not. These make notes simpler to understand. Okay? So nobody says that it's so difficult. I won't pass. I will leave the chapter. Nothing like it. Extremely simple. So please subscribe to the channel and pass the links to your friends. As I remind you, very soon the channel will become private and only registered students will be able to see discussion of question answers, extra questions, exam based questions, difficulties being solved on the board in front, and one-to-one queries solved. All these will be coming just very shortly as soon as we are over with this week or so. Okay, my friends? Thank you very much.